All right, case number 2. In case number 1, we proved that the measure of angle of the inscribed angle was half of the measure of the arc that it was intercepting. So we're going to do the same thing today. In this case, but this time the inscribed angle is the inscribed angle is like the second scenario that we did previously. So the circle O, the point O is in the interior of the measure of the inscribed angle, MPT, that's given. And the measure of angle MPO is, let's say it's X, and the measure of angle TPO, let's say it's Y. And we want to prove the same thing, that the inscribed angle is half of the measure of the intercepted arc. So here we first start a proof all the time with the given. So you write in what's given here. We're going to go ahead and take a screenshot of this, and so we can do some annotations. So then they say to construct the diameter PR, which is already constructed in the picture, and then construct OT and OM, which is also already constructed in the picture. And the next thing we could logically do to try to prove this is to say that we can recognize when we look at this that OM and line segment OP and OT, they're all equal because they're all radii, or they are each a radius of the circle, so they're all equal. And we can annotate this, we can use like a blue, we can say this is equal to this, which is equal to that, using those tick marks. Next, they say that OPM, this is a typo here, so I think this should be OPM. Oh, it says OPM, so it should be OMP, sorry, OMP. So it should be angle OMP is congruent to OPT, and so we can annotate that with like little angle symbols there. And OTP is congruent to OPT, and that would be this angle is congruent to that angle. And that's because if those two sides that we just mentioned are equal to each other, the radii, then it creates two isosceles triangles. And remember, we learned last semester that in isosceles triangles, two sides are equal and the two base angles are equal. All right, so moving on from that, then we can also notice that angle ROM is at plus the measure of angle MOP. They form linear pairs, or they form supplementary angles, right? So they add up to 180, and we can say the same thing for angles ROT and TOP if you want to pause this video to kind of just make sure you can locate those angles so you can follow along. So we know those are supplementary, that means they add up to 180. So because of steps 5 and 6, we can then just say that angle ROM plus ROT plus MOP and TOP, they all add up to 360, okay? So moving on to the last 3 steps, because of this, by substitution, we can therefore say that the measure of angle MOT is equal to 360 minus the measures of angle MOP plus TOP. And then we can also therefore say, we can also by substitution say that the measure of angle MOP is the same thing as 180 minus, excuse me, 180 minus twice the length of angle MPO, sorry. And we can also substitute and replace angle TOP with 180 minus twice the length of angle TPO. And make sure you pause the video and try to see if you can recognize these angles in the picture, and see if you follow. And if you have any questions, please feel free to ask your teacher. Number 9, because of this, we can then say that the measure of angle MOT is therefore going to be twice the length of MPO plus TPO. And this would be true because we can see in the step 8 that 180, you have one positive 180 and then one negative 180, so those would add up to 0. And so that's how we can get to twice MPO and TPO, just some algebra. And then it says the measure therefore could be the measure of angle MOT is then equal to the twice the length of MPT, and this can be because of the addition postulate. We can add those two angles, it would be the total of the inscribed angle MPT. Now, knowing that the central angle MOT is basically twice the length of the inscribed angle MPT, we can therefore then say that the opposite is true, that angle MPT is basically twice as large as the arc, or the arc MT is half of the measure of the inscribed angle, which is that last statement. All right, so make sure you keep those annotations and you upload your annotations to Canvas. Let's go move on to case number 3, if this will help allow me to move. There we go. So here we're doing the same thing but a different scenario. We have an inscribed angle that has the center of the circle in its exterior, and we want to prove the same thing, that the measure of the inscribed angle is half of the measure of the arc. So we always write what's given, and in this case they want us to construct diameter PR, and it's not constructed, so we're going to take a screenshot and make sure we construct it in our picture. So we're going to go ahead and construct the diameter PR and construct OT and OM. Step 3 tells us that the measure of ROM is going to be equal to twice the length of RPM, and that's because of from case 1, if you want to go back to case 1. But basically it's saying that, hey, the central angle is twice the length of the inscribed angle RPM. And from that information we can also come up with noticing that MOT plus ROM plus TOP, all those add up to 180 degrees because they're all linear angles. So let's say that the diameter RP is a line, and so if we add those angles ROM, MOT, TOP, they would add up to 180 because that's the definition of linear angles. Now let's move on to step 5. By substitution, MOT is, we can say, is equal to 180 minus the measures of angle ROM plus TOP, which makes sense. If we want to find the measure of angle MOT, we would have to subtract those other angles that were there, and we knew that they added up to 180. Knowing this, then the measure of angle MOT is equal to 180 minus twice RPM. This is substituted from step 3. And TOP, we can replace it with 180 minus twice the length of angle OPT. Simplifying this, on step 6, the measure of angle MOT is equal to twice the length of OPT minus OPM. Make sure you pause the video to make sure you can locate these angles and really follow through logically through this thinking process. Remember, a proof is simply a thinking process, a process of logically coming to a conclusion. Simplifying this further, MPT is basically the same thing as the measures of angle OPT minus the measure of OPM of the angle there, and that's the same thing as the measure of angle MPT. When we look at this, it's telling us basically that the measure of angle MOT is equal to twice the length of MPT. And knowing this, we can therefore state that the inscribed angle MPT is equal to half of the measure, and this should be, this is a typo, this should be, what we're trying to find is the measure of the arc here. So I replace that there. So we have located, and we've said this arc right here is half of the length of this intercepted arc. That's what we found. This is half of the intercepted arc. Okay? Go ahead, and if you have questions, please reach out to your teacher. This is not easy things to follow. It's supposed to make it hard. We're basically exercising your logical thinking skills here. So basically from those three scenarios, we can come up with the inscribed angle theorem, and it basically says that the measure of an inscribed angle is half the measure of its intercepted arc. So here we have a scenario. Aubrey wants to take a family picture. Her camera has 70-degree field of view, but to include the entire family in the picture, she needs to cover a 140-degree arc. Explain what Aubrey needs to do to fit the entire family in the picture. So if you want, you can go ahead and pause the video to see if you can figure this out. What does Aubrey have to do to make sure that she can get all of her family members in the picture? Alright, if you pause the video, hopefully you did. Hopefully you said that to cover the entire family, she will use the inscribed angle theorem, which we just learned. And so Aubrey must be located on the circle formed by the family members as shown below. Alright, hope you enjoyed this lesson. See you in the next video.